There we go. All right, we're back on customer use cases, and I'm really excited to have a new OpenShift Commons member and new to me case study around OpenShift on OpenShift Dedicated, and Michael Sauter from BIX, and he'll explain what BIX stands for, and take it away. And there'll be we're going to get a little room at the end for a little Q&A with him.
Probably, yeah. Cool. So yeah, this BIX is actually BIX, slightly different. So yeah, my name is Michael Sauter. I work for BIX as a backend engineer. And you probably never heard what BIX is. So BIX is, if this works, doesn't work. No, not happening. Yeah, I'm using the arrow.
And just check. Yes, that's not working. Just hold on a second.
That's okay. Or I'll just use the arrows. That's okay.
Did it slide out? Or the battery may have died.
No, the battery's fine.
No, it's turned on. Turn it on and off again. Not this time.
We'll use the little arrows.
Guess I'll use the arrows. That's okay. No worries. So, what is BIX? BIX is Boehringer Ingelheim's digital lab. And for those who also haven't heard of Boehringer Ingelheim, BI is one of the largest pharmaceutical companies worldwide. And we at BIX, we use digital innovation to accelerate the development of healthcare cures and also the discovery of breakthrough treatments. So we use OpenShift as a platform where we deploy our services to. As a digital lab, we regularly start new initiatives. So it means we regularly work on new products that have something to do with health and digital. And we also hand over successful ones to the larger organization. And in that regard, OpenShift is quite crucial to us because when we develop the initial prototype, we can use OpenShift as a platform to develop our applications against. And then later on, we can transfer those applications into the wider organization using the same underlying platform. And while the lab runs on a different cluster than later on what will run in the organization, it's still the same platform, and it's very easy to transfer. Oh, great. I agree to whatever I'm agreeing. Probably. Okay. And I want to focus a little bit about what these initiatives are, how their life is, how we develop on those. And this will also be somewhat related to the previous talk about open source and enterprise, because we at BIX and Digital Lab, we have a little bit more freedom, and we actually use a lot of open source technology and are also contributors to open source. So everything that you will see, what I'm going to talk about today, is actually also open source. So when an initiative starts, the goal is obviously to develop the MVP as fast as possible. However, there are many boring tasks that are in the way. So every initiative will have the same requirements, roughly, that have nothing to do with what the product is actually about, right? The product might be very exciting, AI technology, whatever. But for the team that works on this, you still need the same setup. So you need something for team collaboration. We use, for example, Jira, Confluence. You need to set those up for the team. Then infrastructure. Yes, we use OpenShift as a platform, but just the platform itself is not enough, right? You need various environments where you have your development, your staging, and so on. You also need to think about CI and CD. How do you build your software? How do you test your code? How do you scan code? How do you analyze code? How do you deploy to OpenShift? And also, many of those initiatives will work with the same primitives. So for example, you might want a Spring Boot application or a Node application, an Angular frontend, an Ionic app. These boilerplates are always the same. And going even a bit further than boilerplates, you might even want the same components. So for example, user authentication, right? We want to have a user service where people can authenticate. We want to try out our idea quickly and not work on the user authentication in every team. So in the startup initiative, you have a lot of tasks that are very boring and very repetitive. None of them provide any value to the user. And most importantly, the team should not have to reinvent the wheel. So if you solve things once in a team, why should the next team have to solve the same problem again if they start from scratch? And we need some form of standardization. So within the digital lab to know what other teams are working on and be able to help out and have the same understanding. But also if you want to do a successful handover, if every project that you want to hand over is a snowflake that the large organization has to take over, they're not going to be happy. So to solve those issues, we built our own devstack around OpenShift. So OpenShift is kind of the platform we are building on, but many things are not a given in OpenShift. It's not prescribed how your process looks like, how your pipelines look like. And so the devstack we built around it solves those issues. And this is not only our devstack anymore. It's open source. That's why we called it the Open DevStack. And it allows you to set up required infrastructure and continue delivery processes for new projects in less than 5 minutes. So it's kind of an opinionated way to develop your applications. Let's step a bit through what you get with Open DevStack to show you a little bit what it gives you. So one part is that you can provision a new project. A new project for us means you will get a Confluence and Jira space set up. You will get an accompanied Bitbucket project set up. You get OpenShift environments. So initially you get 2 for development and staging, and you can add more as you go. And every initiative also gets their own CI/CD setup. So you get your own Jenkins instance. And if you side things around that, which I'll get to later. So with this setup, an initiative is ready to go. There is no code yet, there's no application yet, but you basically have the space in which you can operate. And once you provisioned a new project, you can then go on and provision components. So components, also you can provision them with one click, basically. You pick from a list of quick starters. We call them quick starters. So this, again, might be a Spring Boot application, or a proxy, or a mobile application. And this will provision you a repository with some boilerplate that the developer then is ready to start developing with. You also get OpenShift resources. So for example, for a Spring Boot application, you would get an image stream, a build config, a service, deployment config, a route. So everything will be connected and set up for you after provisioning. And you also get a CI/CD pipeline. So with this provisioning, it can build the code, it analyzes the code, and deploys the code. So basically, after you click provisioning, everything is fully auto-deployed until in the development or staging environment. Let's look a bit deeper into what Open DevStack is made out of. It's basically 4 different components. So we have a core. There are certain things that the other parts need, for example, base images and so on. There is also a setup of the Atlassian products, so Jira, Confluence. There is a central nexus to store artifacts in OpenShift. There is also a central SonarQube server for code analysis that each initiative can use. Then next to the core, there is the provisioning app. This enables users to provision new projects and quick starters within those projects. The provisioning app itself is kind of an example using the same process. It's actually made out of the same quick starter, and it runs within OpenShift, so it's kind of eat your own dog food. It uses the same pipelines. To go a bit more into detail what those quick starters are, quick starters are sort of skeleton apps. The basics would be, for example, for Spring Boot, you run a CLI and you get a Spring Boot application. but it also does some modifications to make it actually run on OpenShift. The quick starter has also the information on how to build that project. So there will be Jenkins agent images that the Jenkins pipeline can use. There is a Jenkins file which describes how to build and deploy this application. It also delivers how to run the application, so the Docker file, the deployment config, and so on. And it sets up OpenShift resources. And finally, there is Jenkins shared library. So this Jenkins allows you to import a shared library into your pipeline, and that allows you to abstract generic tasks you need to do in your pipeline. So for example, the shared library checks out code, it selects which environment to deploy to. It also does a bit of integration. So for example, it communicates build status with Bitbucket. It does a code scan before deploying, and it also builds starts the OpenShift build and the deployment. To have a bit of an example, here on the left-hand side, you see an example of a Jenkins file that is provisioned. It calls a custom function from the shared library, ODS pipeline, where you reference an image, an agent image that comes with a quick starter. It maps branches to environments. So you can say, for example, the master branch should go to test, and all other branches should go to dev. You can set this up whatever you want. And then you can see the stages that the quick starter will do by default. So the thing looks very much like a normal Jenkins file, just that you can define some stages yourself, and other stages you just reference. So for example, in this case, this is a Java project. So it builds with Gradle. The shared library does not know how to build Java projects as such. But it knows, for example, the next step, how to scan and put that to SonarQube, because that's the same for any type of application. Then it starts the OpenShift build and will deploy to OpenShift. Starting the OpenShift build means triggering the build config, which references the Docker file in the same repository. And this is an example of very simple how a default application could run. Now, there are a few nice things in OpenDevStack which are not part of a default setup. One thing, for example, is what we call the webhook proxy. OpenShift has an integration with Jenkins, so you can create a pipeline in OpenShift that will be mirrored in Jenkins. But it is a bit tricky to have basically one pipeline per branch, which is what we wanted. So the workflow is that you push code to Bitbucket. Then Bitbucket will trigger a webhook, triggering the build config in OpenShift. Right? But then you already have some preset build config, and you don't know how many you will need. And we don't want the application developers to set up their own pipelines. So instead of triggering the build config directly, we trigger a webhook proxy. And then this webhook proxy deals with, creates pipelines on the fly and removes them as needed. So with that, you get one pipeline per branch. And this is quite nice for the build history and to keep things separate. We've also built in an ad hoc cloning of environments via Jenkins. So for example, you can say that for in Jira, I have user stories, and for all my user stories, I want to spin up a separate review environment that is cloned from my normal dev environment. I want to have the same OpenShift resources, but I want them separately under a separate URL. So what you can do is you can instruct Jenkins to basically say, okay, for this particular user story that I'm receiving, is there already an environment that matches to this user story in OpenShift? If not, it automatically clones an existing environment and then deploys to the new environment. Then there are, of course, many small things that OpenDevStack provides. For example, that all the quick starters are configured to pull their dependencies via Nexus. So I just use this as an example to to say that often if you just provide an access instance, it doesn't mean that everyone uses them, right? But if you make sure that all the boilerplates people start with are already correctly configured, then those things are actually used. And then the Open DevStack also comes with a few migration scripts to move projects from one cluster to another. So since the lab starts out in a different cluster, we might need to move the project to an in-house cluster, or if we are working with sensitive data, things also need to move between clusters. So that's also part of Open DevStack. Now I want to take a little bit of a detour and talk about one particular thing we built into Open DevStack, or a problem we faced and the solution we came up with. And this problem is basically around how our resources set up. So I talked about that we have a SonarQube instance or Nexus. So if users want to install the DevStack in their own OpenShift cluster, how do you actually set up those things? So as many of you know, I guess there are ways to do this. You have templates, you have a manifest that you can bring up. So this is kind of solved. But afterwards, so say you have an instance deployed, then later on a new version of Open DevStack comes around and you want to see what has changed. What is the difference between what the new version is and what is running in my cluster? What is the drift? How do I detect that drift, and how do I review what the difference is? And finally, once you know what the drift is between two different clusters, two different configurations, how do I sync them back up? And we didn't find a solution that was very easy to use. It's still based on the OpenShift templates, and that is very low entry, basically. So we developed a small tool on top of the OC commands, which does that. I call this as basically a Terraform for OpenShift. I guess most people know Terraform. Of course, Terraform has a lot of providers. It doesn't have like a nice OpenShift target, so to say, where you can manage your deployment config or your build config via code. So this, I think, is partly because there is some weird mixture between config and state in the resources in OpenShift. So this Tailor is a standalone tool. We use it a lot in Open DevStack. So basically, when you install Open DevStack, you set up all the infrastructure on OpenShift with this tool. And when new versions come around, you can update with this tool. How it works is pretty simple. So first, you get the desired state. This is what is in your templates. So your OpenShift templates, we use OC process to process them with parameters, and then compare the desired state with the current state, which is an export from your cluster. You compare that, you get the drift. You can see this as textual diff, so people can review what the differences are. For example, you add some new environment variables to your deployment config, and Tailor can then generate JSON patches from that and pass these JSON patches to apply those updates. This is crucial because the standard OC apply, for example, does not delete configuration there. So, for example, if you want to change the deployment strategy of a deployment config, you cannot do that with OC apply because it will not delete the other deployment strategy. So you will need to use OC patch, and OC patch is tricky to use if you don't have a tool that generates those patches for you, because you need to all write them by hand. So Tailor does it by himself. It figures out what to do and does that. So yeah, it's, as I said, a standalone tool. So if you want to do something like that, that's pretty cool to also you can manage your whole resources that way. And it's very low entry because you still use the standard OpenShift templates. There is no need for a different tool. So with that, a bit of a summary. So with Open DevStack, you can focus on the development, not the process. There's extremely fast ramp-up time. So if you have lots of projects or initiatives in your organization, that's a nice tool to have that. We try with it to solve one the problems once for all the teams. So if there is some kind of glitch, we solve it once. And OpenDevStack tries to integrate tools very tightly. So for example, the integration between OpenShift, Jenkins, and Bitbucket, I think is very nice that you don't get out of the box. And all of that, what I described, is completely open source. So at github.com/OpenDevStack, and we basically run our DevStack just based on that. Thank you.
So that's the second new open source project that I've learned about today. The first one was the Tremolo's Orchestra and your OpenDevStack.
OpenDevStack. And
so it is
Tailor
possible to contribute back.
It is possible, yes. So we made through this dance of what was previously described of can we contribute and what will that mean and so on. But it is possible. So if you have any questions, let me know afterwards or on Twitter.
All right.
Yeah.
Or when we're having beer this evening.
Or yes, later.